bestrobo.in, your favorite robotic and electronics store in India.
Hello everyone, welcome to Mifratech. Today in this section we learn about Arduino Nano microcontroller. So this is how Arduino Nano microcontroller will look like, as you can see here. So this Arduino Nano is a small and complete breadboard friendly microcontroller. It has mainly a Atmega 328P IC built in it. It offers the same connectivity and specs of it is like exactly like Arduino Uno board only, but it is a smaller form of factor. So this Arduino Nano is equipped with 30 male input output headers, and it has a DAP30 like configuration is there, and you can program for this Arduino Nano also using Arduino IDE, that is integrated development IDE environment, and it contains a word bootloader in it. The board can be powered through a type B micro USB cable. So in order to dump the code or in order to provide the power supply, you can make use of this type B micro USB cable, or you can also provide supply through a 9 volts battery. So next we'll see the pin details about this Arduino Nano microcontroller. As you can see, it mainly has 14 digital pins, that is from, as you can see here, that is from D0 to D14, D13, D0, D1 up to D13. As you can see, 14 digital pins are there. In that D0 and D1 can be used for receiver and transmitter pin, for like in the example, like if you are connected RFID or any in this, for that transmitter and receiver communication, you can make use of these D0 and D1 pin. And after that, it has some analog pins also in it. As you can see here, there is a 8 analog pins from A0 to A7. These are the analog pins in order to collect the analog data. Next we have ground and V-in, that is V-in in order to provide a power supply for this Arduino Nano microcontroller, you can provide here. Then there is a ground button. Next we have a reset, and there is a 5 volts button. This will provide a 5 volts from Arduino Nano microcontroller. Next we have a reference and a 3 volts 3 this is in order to provide 3.3 volts the board will provide. And they have a pin number D13, that is digital pin number 13 can be used as serial clock, and analog pin number A4 and A5 can be used for a serial communication, that is I2C, that is serial data and serial clock. Next pin number as you can see, this is D11, pin number 11 and 12 of digital pins can be used for SPI communication, that is master out serial in and master in serial out, that is slave out, master out slave in and master in slave out. For this SPI communication, you can make use of the digital pin 11 and 12. Next we can also find a ground and reset on this digital pin side also. So these are the different pins present in this Arduino Nano microcontroller. It has mainly Atmega 328P IC microchip present in it. So next we will see the pin configuration. So first we have a power. You can provide mainly there are 4 power pins, that is V-in. This is in order to provide input voltage to Arduino. You can use an external source. You can provide voltage between 6 to 12, or you can also provide a 5 volts DC voltage for it. Next one you have 3.3 volts. So this 3.3 volts supply is generated by the board itself. So you can, in order to provide a 3.3 volts to any sensors or actuators connected to it, you can provide through this pin. And then we have a 5 volts pin, that is it will provide a regulator actual 5 volts power supply microcontroller will provide. You can use for other components. And there is a ground pin, this is in order to connect ground. So next we have a reset pin, that is in order to reset the microcontroller. Next we have 8 analog pins, that is from A0 to A7. This is in you can connect to any analog sensor, or you can connect to sensor in order to connect the analog values. Next we have 14 digital pins from D0 to D13, as you can see. So those are the digital pins in order to connect the digital data. Then we have serial pins, that is for serial communication you have RX and TX, that is pin number D0 and D1. Receiver and transmitter you can use for serial transmitting and receiving of data. Next we have external inputs, pin number 2 and 3, that is the digital pins can be used for triggering an interrupt. And we have PWM pins, that is pin number 3, 5, 6, 9, 11. So these are the different pins you can also use for pulse width modulation purpose. And they have SPI, that is a serial peripheral interface. For SPI communication you can use pin number 10 as a slave select, pin number 11 as master out slave in, and pin number 12 as master in slave out, and pin number 13 for serial clock. Next we have inbuilt LED also in it, that is pin number 13. And you can also use analog pin A4 and A5 for a TVI communication, that is a two-wire interface communication, that is serial data and serial clock. Then we have a reference, that is a reference voltage for input voltage. So these are the different pins present in Arduino Nano microcontroller. Next we will see what are the features of this Arduino Nano microcontroller. Mainly it has a microchip, that is ATmega 328P. The operating voltage is 5 volts. Generally we will provide 5 volts DC supply in order to turn on, or we can also provide through a micro USB cable or through DC jack or battery you can provide. The input voltage is 6 to 20 volts, and it has a 14 digital pins, that is from D0 to D13. In that 6 can be used for PWM output pins. It has 8 analog pins from A0 to A7, and DC current per input pin will be 40 milliamps. It is compatible than Arduino Uno. So other features are like it DC current for 3.3 volts pin is 50 milliamps. It has a flash memory of 32 KB. In that a 0.5 KB can be used by bootloader. It has a static RAM of 2 KB, EEPROM of 1 KB, a clock speed also 16 MHz. It has a length of 45 mm and width is 18 mm. So this, what are the application or where exactly you can make use of this Arduino Nano microcontroller? So wherever you want to use any microcontroller in your project, or in order to do like home automation or agricultural project or any other projects, you can make use of this Arduino Nano microcontroller also, like in developing project based on core based controller, development of automation system, designing of basic circuit designs. So what are the features of this main IC present in this Arduino Nano microcontroller is ATmega 328P. It is a high performance 8-bit AVR RISC based microcontroller. It has a 32 KB flash memory, as that it can be read and write type of flash memory, and there are 23 general purpose input port lines, and there are 32 general purpose working registers present in this IC. It has 3 flexible timers or counters with it. You can using that you can generate internal and external interrupts, and it has a serially programmable byte oriented 2-wire serial interface and serial port, a 6-channel 10-bit analog to digital converter, a programmable watchdog timer is present with an internal oscillator also it has. It has a 5 software selectable power saving modes. The device mainly operates between 1.8 to 5.4 volts. This IC will operate. So this is the pin diagram of this ATmega 320P IC, as you can see here. So next we'll see how to install Arduino and how to dump the code using this Arduino Nano microcontroller. First, in order to dump the code or in order to provide the power supply, you have to use this USB micro cable, as you can see here. Using this cable, we'll connect to this Arduino Nano microcontroller to the system, and we'll dump the code or we'll provide power supply through this also. So first we have to download the Arduino IDE in order to do the programming. After downloading Arduino IDE, as you can see, this is the Arduino IDE downloaded file will look like. Next you install this in your system. Next, after that, launching Arduino IDE, this is the home page will look like. In this go to file and open your first project. After that, as you can see, there are a lot of examples for different LEDs or relays and different sensor programs are already available. You can refer those. And you can first you have to select the board here, then go to tools. There, as you can see, there is a board option. In that board, have to select the Arduino Nano, because I am using a Arduino Nano microcontroller. After selecting the board, have to select the COM. So that is COM is nothing but serial port. So in the tools also you can see after the board there is a serial port option. In that, if you have already connected through the USB micro cable that your Arduino Nano microcontroller to the system is, the COM is serial port COM will be showing like this. After that, select you have to select that COM. So after selecting the COM, in order to compile the code or to upload the code, these are the different options available. As you can see, the first one right mark like that. This is in order to compile the code. If any error is there, means after compiling error will display. Otherwise, compilation successfully done, like that you will get a message. After that, there is a right arrow mark is there. That is in order to upload the code to any Arduino board. So using this, we can dump the code to the Arduino Nano microcontroller board. After that, there is one more shortcut in order to create a new sketch, that is in order to write a new program. There are two D and D, as you can see. This is in order to directly open one example of the sketch, or used to save your sketch. We can make use of these buttons. And at the most right end, as you can see, there is a F I have mentioned here, that is a serial monitor button. That's there. If you click on that, or if you are seeing any output data or any output you are printing in a serial monitor, means there you can see the output. So next we'll open we'll see the what is the general structure of Arduino program is. Mainly it has two structures, as you can see. void setup and void loop. In the setup you have to define what are the devices connected, you are using them as an input or output, that you have to mention in the setup. Or if you are using serial monitor means baud rate you have to set. All those things you can do in the setup. And in the void loop, in the loop, that is we have to write the exact code. That is why you are writing in the loop function means the code has to be executed repeatedly. That is, if you are using any sensor means the sensor has to continuously fetch the data and send the data to the microcontroller. So only we are writing in the loop. So these are the mainly two components. So as I told earlier itself. So next here we will write an LED. In this example I am going to show you how to connect an LED to this Arduino Nano microcontroller and how to program it. So the main components related is Arduino Nano microcontroller board and a jumper wires and one LED. So this is how our interface will look like. As you can see, LED has mainly two pins. The long one, as you can see, this we have to connect to ground pin. So I am connected. So the slightly bent color, as you can see, that is a positive pin that I am connecting to a pin number 13, that is digital pin number D13 of Arduino Nano microcontroller through a 330 ohm resistor. So this is the simple way in order to interface this LED with Arduino Nano microcontroller. So for that Arduino Nano microcontroller we have to provide the power supply. So I am providing power supply and ground through a 5 volts DC. You can provide through adapter, or you can also directly provide through this micro USB cable. So after interfacing, the next we'll see how to program it. So this is how LED will look like. As you can see, the longer red will be the positive, next one is the negative. So then go to a file, again open a new sketch, then write your program. So the program will look like this. As you can see, I have connected LED to the pin number 13, that is D13 of Arduino Nano microcontroller, that I am initially defining here int LED pin number 13. After that I have to set up. So LED mainly I am using as output. So I am using in the setup, I am defining the pin mode. So pin mode of LED underscore pin I am making as output. After that, in the loop function I am writing the actual code. What I am doing is, for a particular time I am turning on the LED. After some delay I am again turning off the LED. So in order to turn on the LED I have to use this as I connected it to digital pin, I have to use a digital write of LED underscore pin. This is the pin number 13. I am making high. I means I am sending a 5 volts supply to that pin. So and at that position the LED will turn on. So after that I am giving a 500 milliseconds of delay. Again after that I am making digital write of LED pin low, means I am sending 0 volts, that is nothing but I am turning off the LED. After that again a 500 milliseconds of delay I have given. So this code will be running continuously because I have written in the loop function. So what happens is, after a 500 milliseconds of delay, LED will be like turning on and turning off automatically. Like this in way you can interface this LED to Arduino Nano microcontroller and you can run it. In the same way you can use this Arduino Nano microcontroller in a different application like home automation or agriculture project. There are different areas where you can make use of this Arduino Nano microcontroller. So thank you for watching the video. Thank you.